Let's look at the next plant growing simulation prep sheet solution. So this is number 36. A new feature randomizing the starting field is to be added to the simulation. Create a new randomized field subroutine to meet the following requirements. The user is asked to enter the total number of starting plants. This number must be bigger than or equal to 0 and no greater than the number of total plots available on the field. The user is asked to enter the total number of starting seeds. The user must be bigger than or equal to 0 and no greater than the total number of plots available on the field minus the number of plots assigned for plants. So the plot is one square on the field. The user is asked to enter the total number of starting diseased plants. So this bit you can ignore because I changed the order of the task so the disease comes later. So don't worry about that for now. Let's delete that. The simulation should then populate the field at random according to the values input by the user. Right, so again, a new subroutine. Let's do it at the top. And we need to define it. And there are a series of inputs and a series of validations that need to take place. So quite similar to the last task and also a previous task. Let's just get that done quite quickly. So the first one is the number of plants. So let's say num plants equals num plants is an integer, and we input how many plants do you want, and the number must be bigger than or equal to 0. So while num plants is less than 0, or num plants is bigger than the total number of plots available on the field. So how will you work that out? So you, in the last task, you re-implemented it so that the length and the width are in fact variables. Notice that I've started a new file because each task can be completed separately. But if you've got the variables in your solution, then use the variables. In my case, number of plots, I'm going to still use the constant. So how can we find out the total number of squares? Well, we know the dimensions. It's a square, so we can just multiply them together. So we can't have more plants than there are plots, because that then might cause the random generation later to cause a crash or something. So let's say invalid input, please re-enter. And then let's do the same thing again, but this time for the number of starting seeds. So let's call this variable num seeds. How many seeds do you want? This number must be bigger than or equal to 0, so num seeds can't be less than 0. And it no greater than the total number of plots available minus the number of plots assigned for plants. So it can't be bigger than the total number of plots, take away however many plants we have. So that will work. And we need to then populate the field at random according to the values input by the user. So the idea is, rather than the simulation starting with just one plant in the middle of the grid, we want to make it so that we place however many plants they want at random across the grid, and we place however many plants they want, however many seeds they want at random across the grid. So we want to do something like, while the number of plants is bigger than 0, let's put the plants first. We want to find a position, so a row and a column position So which row, which column should we put the plants into the field? And you'll notice we'll probably need to already have the field. Think about how this is going to work. Are we going to create a new field? So here you might need to read ahead. So we want to call this subroutine from initialize field. So we could do it either way. We could call create new field from randomize field, or we could pass in a blank field to randomize field. Let's do it the other way. So we're going to make it so that at the start of randomizing a field, we create a new field, and now we're going to take the field and we're going to at random add in plants. So this is similar to the rock placement algorithm that we did in a previous question. So we're going to rand range between 0 and the length of the field to get the random row, and the same thing with the width of the field to get the random column. If we find that that is something that is a blank space, so if we find a blank space, and a blank space is a soil, right? Then what that means is we can put a plant in this space. Then we can decrement num plants by 1. And what this will do is it will make it so that if we try to put a plant in a position where there's already a plant, it won't decrement num plants, and it will just go to the next iteration and it will generate a new random number, or 2 new random numbers. And then it's going to be the same thing for seeds. With num seeds instead. And this time we're going to add a seed to the grid. At the end of this function, we probably want to return the value that we've changed. And again, it's not really something we can test in isolation without importing it from the program. So let's do task B as well. So amend the initialize field subroutine to allow 3 options instead of just 2. So let's find this prompt where we're asking the user how they want to make the field. And this time they've got L for loading a field from file, or N for creating a new field. And then otherwise, let's just presume that they've entered R, and let's do the random field method. Randomise field was the name. Let's test it. Let's see if it works. So what we should see now is syntax error, which is always fun. Let's find line 23. And again, the same thing. Brackets missing, same as the last video. Let's try that again. Another syntax error, so single equals. So look, I'm pressing Control F to find the line of code referenced by the error message, or the section of code referenced. Let's try again. Okay, got some success. So the test we need to do is start the simulation. We don't have the last feature in place, so the user decided dimension. So we'll skip past that bit. Let's just put it into stepping mode. Let's choose random field. How many plants do you want? Will be 101. In this particular test case, that's not going to be invalid because there is a bigger number of plots available, because in this case it's 20 by 35. So this test is going to be a little bit different because the way that this test case is written is dependent on you having the last question completed as well. So let's just ignore that for a second. Let's pick some ridiculously big numbers. That's too big. And let's do 50. 50 will be accepted. And then it moves on to the seeds question. Let's set the starting number of seeds to something too big. So 20 times 35, 700. Let's try 701. And, ooh, seems like I've got some sort of logical error here because my program is stuck in a loop, it seems. Let's have a look at why that might be. Interesting. So I've seen one mistake here. I've referenced num plants, but that should have been num seeds. But I don't see why that should have caused that error. Let's try again. Let's see if we can recreate that same error of it seemingly getting stuck in some sort of infinite loop. Random. Let's just put in some valid values. So 701 is too many. Okay, this time it seems to reject it. Let's put in 651 should still be too many. 650 should be allowed. Okay, so this is helping me narrow down the problem. I can see that there's no problem with the inputs. It seems like there's a problem with this while loop, or one of these while loops never ending. Why might that be? So for some reason, the random generation of the row and the column is meaning that it's always picking something where this statement must be false. So let's think about this. So when the field is first created, it's coming as a result of the create new field function. Let's look at what the create new field function does. It uses this list comprehension to put a soil in every plot in the 2D array. And it puts something in the middle. Could that be causing a problem? It puts the seed in the middle, and then it returns the field. So to help me to debug this, I'm going to put in some print logs. And this is what you will need to do in real time in the exam. Let's print out the field. Let's put a little message saying debug. Let's see if we can work out what the problem is. Let's do the test again. So we want to have 50 plants, and then 650 should be a valid number of seeds. I think I know the problem. So the problem at the moment is that we have got, we are allowing the input of 650, but there are not in fact 650 soils left in the grid. This is because when you first run create new field, we've got one seed. So that means the available number is 649. So the problem is that this won't ever be able to get lower than 1. So if I print out the value of num seeds, that should be what's causing the problem. And we'll be able to see that it will hang on 1, meaning that we get an infinite loop because there are no spaces left to put a seed in the field. Let's try that again. Whoops. Try that again. -1 and R, 50 plants, 650 seeds. Debug. So we can see that it counted down. It was able to put in 649 seeds, but there wasn't enough space left on the grid to put that last seed. So we need to think about this. So perhaps it isn't suitable for create new field to be used because create new field puts in that one seed in the middle. So instead, maybe let's just duplicate the list comprehension and let's create the field using the list comprehension just with the soils instead. That should solve our problem. So it's important when testing to do these edge cases, like, okay, what if I put in, if I try to fill the grid, or these boundary cases, I should say. So 50 plants, 650 seeds, printing out the grid. We can now see that it works. So in this case, because we didn't have that one in the middle, there were 650 free spaces to put the seeds in. Let's just do a few more tests. So let's say, let's quit the program and run it again. Does it work if we want 1,000 plants should be rejected? 35 plants should go in. What about if I want minus 500 seeds? It should be rejected. If I want 1,000, it should be rejected. Anything below 700 minus 35 should be acceptable, right? So 665 is allowed. And that fills the entire grid with plants, it seems. Shouldn't some of them be seeds? No. So we don't actually get to see them being seeds because the first season that runs is spring. And the function of the simulate spring subroutine is to change every seed into a plant. So even though we're putting starting seeds, we don't display until spring has already begun, so we actually end up seeing only plants. Interesting. So yeah, that's like an implementation thing. Like, is there any point asking for seeds? You might as well just ask for plants. But if that came up in the exam in that format, you need to just follow the question and do whatever the exam told you to do. Okay, so that was the solution to number 36, which is about randomizing the starting state of the field.